All right, so this is a key to the worksheet on solving quadratic equations by completing the square. And there were two problems you had to work on. Make sure you always follow the directions. So the direction said solve each quadratic equation by completing the square. Don't use any other method. And then you needed to show all steps and make sure you're using the two practice worksheets so that you will know exactly what the work should look like. All right, so let's look at number one. So number one, we have this quadratic equation, and it's 3x squared minus 2x equal 21. Now I want you to notice that this quadratic equation is not in standard form, meaning that 0 is not on the other side. But that's okay in this particular case, because one of the things you want to do when completing the square, and by the way, this was a resource given to you in your Canvas course. But what you want to do when completing a square, when solving a quadratic equation by completing a square, is you want to get the coefficient of x squared to be a 1. So if the coefficient of x squared, if this number that you're multiplying x squared is not a 1, then you're going to divide both sides by that number. And so that's going to be step one, because notice that in this quadratic equation, x squared has a coefficient of 3. And so we're going to go ahead then and divide both sides by 3. So let me go ahead and rewrite this over. So remember, what you do to one side, you have to do to the other. So I'll just write it like this. So the left side by 3 and the right side by 3. Now notice that on the left-hand side, you have this polynomial divided by this monomial, right? So what you want to do next is to rewrite this as separate fractions. So you're going to have 3x squared divided by 3 minus 2x divided by 3 equals, and then 21 divided by 3 is 7. I can also simplify 3 over 3, which is what really should happen, because remember, you want x squared to have a coefficient of 1. So if a does not equal 1, then you divide both sides by a, by that number, to get that coefficient to be a 1. And when I do that, 3 divided by 3 is 1. 1 times x squared is x squared. So I get x squared minus 2x, 2/3 x, equal 7. All right, so that is step number one. So step number one was to basically get the coefficient of x squared to be 1. Step number two then says this: we're going to rewrite the equation so that both terms containing the variables are on one side of the equation and the constants on the other. In this case, it's already the case, because remember, our original problem was the situation where the variables, the terms that contain the variables, was on one side and the constants was on the other. So step two is already done. Step three. So step three says you're going to take half the coefficient of x. All right, so this is x right here. This is x squared. So the coefficient of x is a negative 2/3. So let's go off to the side and let's do that step. So I'm taking the coefficient of x, which is negative 2/3, and I'm going to take half of that. So remember, taking half, dividing by 2, means the same thing. So you're going to change this division to multiplication. So this expression right here, negative 2/3 divided by 2, means the same thing as taking the numerator, the fraction that's in the numerator, and multiplying it by the fraction, by the reciprocal of the fraction that's in the denominator. So the reciprocal of 2 is 1/2. And then simplifying this, the 2 goes into 2 one time, 2 goes into negative 2 negative one time, and I get a negative 1 times 1 is a negative 1. 3 times 1 is 3. So when I take half the coefficient of x, so this part right here, that first part of that sentence, I get a negative 1/3. Okay? Now, the next part of that sentence says I'm going to square that. So I'm going to square that value, that result. So I'm going to take negative 1/3 and I'm going to square it. Oops, square it. And when I square negative 1/3, remember that means a negative 1/3 times a negative 1/3. A negative times a negative is a positive. So a negative 1 times a negative 1 is a positive 1. 3 times 3 is 9. Okay? All right. Now, just to make you aware, and sometimes this helps, that number you get at the end, once you square it, just make sure that the numerator and the denominator are perfect squares. They're supposed to be perfect squares because you're squaring the numerator and the denominator. So the result should be a perfect square. So just verify that, because what some students will do is they'll say 3 times 3 is 6. And so they'll put 1 6 without really thinking about what just happened. But 6 is not a perfect square. All right, so just use that as a guide. All right, so that was step 3. Okay, step 4 then says I'm going to add that square. I'm going to add this number here, this 1/9, to both sides. All right, so I'm going to get this now. I'm going to x squared minus 2/3 x plus 1/9. It's always going to be plus here because you're adding. And 7 plus 1/9. Okay? All right, so that was step 4. Step 5. One side should now be a perfect square trinomial. So you're going to write as a square of a binomial. So this trinomial right here, if you did all this work correct, all this right here correct, then this trinomial should be a perfect square trinomial. And a perfect square trinomial means that when you factor it, so if I look at this in terms of factoring, so if I factor this as 2 binomials, what's going to happen is that these binomials are going to be identical. So let's do that trial and error, that reverse FOIL. So x times x is x squared. Now let's do the last. So the last sign is always going to be positive here. So that means that these signs in here are the same, and they're going to be that middle sign. So I'm going to have x minus, x minus. And then remember this right here, well, we said that this is a perfect square trinomial, right? So these terms in here should be identical. So whatever I put here, right here, better be the same as this. So what fraction times itself is 1/9? Well, that fraction is 1/3. And it kind of makes sense because if you look at this, that's a negative 1/3, and what you see here is a negative 1/3. And so a negative 1/3 times a negative 1/3 is a positive 1/9. And if you check the out and the inner, just to show you, if you check the out and the inner, the outer, x times a negative 1/3 is a negative 1/3 x. The inner, negative 1/3 times x, is also a negative 1/3 x. So these have to be identical because the binomials are identical. And when I add the out and the inner, a negative 1/3 x and another negative 1/3 x is a negative 2/3 x, and that is that middle term. Okay? So now notice that this binomial times itself, I can write as a binomial square. And that's what that should be minus 1/3. And that's what the step right here says. You're going to write as a square of binomial. So basically what happens now is that this is going to be x minus 1/3 squared. And then that's going to equal 7 plus 1/9. Okay, so hopefully for this one, you could use your calculator, but just think about what's happening here. You have 7 plus 1/9, right? Well, 7 plus 1/9 means the same thing as 7 and a 9th, right? That mixed number. And then you want to change this mixed number to an improper fraction. So 9 times 7 is 63. 63 plus 1, 64. So you get 64 divided by 9. So that goes here. Oops, 64 divided by 9. Okay? And you could have used your calculator, or if you wanted to, you could have done this by hand by finding the least common denominator. So the least common denominator of 1 and 9 is 9. So you're going to write 2 fractions with that denominator. So 7 divided by 1 is equivalent to what fraction with 9 as a denominator? And 1/9 is equivalent to what fractions with 9 as a denominator? Well, if you look at this one right here, the 1/9, well, 1/9 is equivalent to itself. So 1/9, 1/9. 7 divided by 1 is equivalent to what fraction with 9 as the denominator? Well, what you learned, one way to do this is to say 1 times 9 is 9, and what you do to the denominator, remember you're going to do to the numerator. And so 9 times 7 is 63. And then 63 ninths plus 1/9 is 64 ninths. and that's what you saw here. Okay, and you have access to a calculator, so you could have said 7 plus 1 divided by 9 equals, you get this decimal, but you want to change this decimal back to, in this case, to a mixed number. So you're going to say, the way to do that is going to say second PRB right here, and fraction to decimal, decimal to fraction. You're going to press enter or equal, and you get 7 1/9, which is what we saw here. And then you just convert that back to an improper fraction, and that's what you write. Okay, so several ways to determine what 7 plus 1/9 is. All right, now at that point, so this is where you're going to use the square root property. So number 6 says use the square root property to complete the solution, to find the solution. So we're going to go ahead and rewrite this over. And what we have is this now. All right, so I'm going to take the square root of both sides. And remember, when you take the square root of both sides, you get that plus or minus, that notation. And so the square and the square root undo each other. So you get x minus 1/3 equals plus or minus. And you're going to simplify this. And it turns out that 64 and 9 are both perfect squares. So the square root of 64 is 8, and the square root of 9 is 3. And so notice that all of these numbers in here are rational numbers. Since those are rational numbers, remember what I want you to do. I want you to tell me exactly what that rational solution is. So at that point, you're going to split it up into two equations. So this says x minus 1/3 equals a positive 8/3. And then x minus 1/3 equals a negative 8/3. And then you just solve for x. And this is not that bad because the denominators are the same. So it should be easy for us. So we're going to add 1/3 to both sides. And so I get x equal, this is 0, negative 1/3 and a positive 1/3, 0. 8/3 plus 1/3 is 9/3, which equals 3. All right, so you're going to say x equals 3. Don't leave it as 9/3 because we expect you to know that 9/3 is 3. Over here, you're going to add 1/3 again, and negative 1/3 and positive 1/3, 0. X equal negative 8/3 plus 1/3 is a negative 7/3. Okay? And you cannot simplify that. I would leave it as an improper fraction. You can write it as a mixed number if you want to. You don't have to, but just make sure if you do that you write it correctly, because any error in here, any error, you cannot receive full credit because you have some mathematical error. All right, so when you write this as a mixed number, then it will be negative 2 and 1/3. All right, but most students will leave it as an improper fraction. Reduced, as long as it's reduced. All right, so that was number 1. You found your two solutions. Those are your rational solutions. All right, so let's look at number 2 now. So number 2, we have this equation, this quadratic equation. Again, you want to use completing the square. And so here's number 2. Number 2 is 4x squared plus 3x minus 7 equal negative 5. All right. Now you can see from here that the coefficient of x squared is not 1. So you know you're going to have to divide both sides by 4, right? But what I would do first, before I even do that, is notice that you have constants on both sides. So at this point, I'm just going to go ahead and before I divide both sides by 4, I'm going to go ahead and bring the constants to the other side. So I'm going to add 7 to both sides. That's going to make things a little bit easier for us. And so when I do that, I get 4x squared plus 3x equal negative 5 plus 7 is a positive 2. All right. Now at that point, remember our step is to divide both sides by that coefficient of x squared. So at that point, I am going to divide both sides by 4. And so I'm now going to write this left-hand side as two expressions, two terms. And so I get 4x squared divided by 4 plus 3x divided by 4 equals, and let's just go ahead and reduce this. That's going to be 1/2. Okay, So now we're going to go ahead and reduce this. 4 divided by 4 is 1, which is what we wanted, right? Because we wanted x squared to have a coefficient of 1 plus 3/4 equals, 3/4 x equals 1/2. All right, so that's where I'm at. Okay, so now the next step is to take half the coefficient of x. Well, the coefficient of x here is a positive 3/4. So I'm going to take half of that. Well, taking half means the same thing as multiplying by half. So we're going to take the fraction that's in the numerator, which is 3/4. I'm going to multiply it by the reciprocal of the denominator, which is 1/2. And then when I reduce and multiply, which I cannot reduce, but I'm going to go ahead and multiply those two fractions. 3 times 1 is 3. 4 times 2 is 8. So I get 3/8. So now the next step, though, is to square that. So all I did was take half. So be careful. Don't add that yet, because remember, one of the things you got to remember is that number you add to both sides. That number you add to both sides, in this case it's a fraction right here. The numerator and the denominator must always be perfect squares. And so if I made the mistake and added 3/8 to both sides, well, for one thing, both 3 and 8 are not perfect squares. All right, so I know that I haven't finished this part yet. So the part I haven't finished was the fact that I have to square that number, 3/8. So I'm going to take 3/8 and I'm going to square it. Well, 3/8 squared means 3/8 times itself. And so if I multiply this out, 3 times 3 is 9, which is a perfect square. 8 times 8 is 64, which is a perfect square. And so I'm going to add that to both sides. So that's going to be step 4. Add the square to both sides. So now what I have is this. I have x squared plus 3/4 x plus 9/64 equals 1/2 plus 9/64. Okay? All right, now if you did all this correct, all this work right here, correct, then this should now be a perfect square trinomial, meaning that you can write it as a binomial squared. And it's easy to do. So you all know what this is going to be, because this is just x squared. So this has to be x, right? And if you want to think about it, then go ahead and do that. So we have x squared plus 3/4 x plus 9/64. But at some point, you're not going to need to actually work it out. You could come here and you could guess or determine right away what goes here. But if you need to, go ahead and do this first. So x times x is x squared. The last sign's positive, so it's going to be that way. And so that since the last sign's positive, that means these signs in here will be the middle sign here. So they're both going to be x plus, x plus. And then all you do to figure out what goes here, and they have to be identical, is think about, well, what fraction times itself is 9/64? Well, what number times itself is 9? Well, that's 3. What number times itself is 64? Well, that's 8. And it kind of makes sense because this right here is 3/8. So you can say 3/8, 3/8. And then what you're probably going to ask yourself though is all right, well, I know that the first times first is x squared, last times last is 9/64, but how do I get that 3/4 x, right? Well, that's your outer and your inner. So let's look at that. The outer, when you multiply those two terms together, that's going to be 3/8 x. The inner, when you multiply those terms together, that's also going to be 3/8 x. And they have to be the same because those binomials are the same. And now when I add them up, 3 plus 3 is 6, right? So 3/8 plus 3/8 x is 6/8 x. And then reduced, that is 3/4 x. And that's what you had here. Okay? All right. So then what goes here then is going to be x plus 3/8 squared. And then that's going to equal, now we just got to figure out what 1/2 plus 9/64 is. So you could do several things. You could use your calculator. So you could say 1 divided by 2 plus 9 divided by 64 equals, and you get this decimal. So since that's a 0 right here, since that's a 0, on the left hand side of the decimal, then you can get a proper fraction. It will not be a mixed number, but you're still going to say second PRB right here, and then press equal, and you get 41 over 64. So 41 over 64 goes here. If you do it by hand, let's say, you're going to say 1/2 plus 9 over 64. So the least common denominator is 64. So you're going to write two fractions with 64 as the denominator. This part's easy right here, right? Because 9/64 is equivalent to itself. And over here, you're going to have to say, well, 2 times 32 is 64. So that means 1 times 32 is 32. So 1/2 is equivalent to 32 over 64, which makes sense because 32 and 64 have a common factor of 32. So that's 1, that's 2. So they're equivalent. And so 32 plus 9 is 41, and so I get 41/64. And that's what you see here. Okay? All right, now at that point, you're going to take the square root of both sides. So let me just go ahead and rewrite this over. So you're going to take the square root of both sides. Oops, 64. Just like this. Don't forget that notation, plus or minus. The square and the square root undo each other. So you get x plus 3/8 equals plus or minus. Now the square root of 41 is not a perfect square, so I'm just going to go ahead and rewrite this as square root of 41 for right now. But 64 is a perfect square, and the square root of 64 is 8. Now before I go on, we have one more step to do. But before I go on, you want to make sure you can, if you can, that you simplify the square root of 41. Well, 41 is a prime number, and so the square root of 41 cannot be simplified. So I cannot do anything else to that. I do want to kind of remind you of something. So remember in the previous problem, we stated that 8/3 here and negative 1/3 and plus or minus 8/3 are rational numbers. They're rational numbers. So that means then that you're going to write your answer as a rational number. Okay? Well, the square root of 41 is just looking at square root of 41. That's not a rational number. That's an irrational number. So this whole fraction right here is irrational. So you have a rational number and an irrational number. They're not alike. One's rational, one's irrational. They're both real numbers, that's true, but you cannot combine them as one fraction like you did this. All right. So basically the point being that all you got to do is bring that 3/8 over and you're done. So basically you're going to say this. You're going to subtract 3/8 from both sides, and you can skip that step. But you have to say x equals negative 3/8 plus or minus the square root of 41 divided by 8. And so you have your two solutions written like this. You could also, if you want to, since both denominators are 8, you can write it like this. Negative 3 plus or minus the square root of 41, all of that divided by 8, right? Or if you want to, you can even go any further with that. You can then say, well, I'm going to write this as two separate solutions. Well, that's fine. You can say this. Negative 3/8 plus the square root of 41 over 8, comma, negative 3/8 minus the square root of 41 over 8. You can do it like that if you want to. You can even write this in as one fraction. You could say negative 3 plus the square root of 41 over 8, comma, negative 3 minus the square root of 41, all of that divided by 8. So multiple ways of writing the irrational solutions. All right, so that is it. So that is the key to the worksheet on solving quadratic equations by completing the square.